Okay, so in this video, we are looking at stationary points, right? But what are stationary points? So let's have a look here at the GeoGebra. So let's look here at the relationship between the slope of my tangent line and like maximum and minimum points. So if we notice here, right? When I move my tangent line across here, that's when my graph is a minimum here. See how my line becomes perfectly horizontal, right? So my line here becomes perfectly horizontal, i.e. the slope of my tangent line is going to be 0, i.e. my first derivative is equal to 0. So wherever my first derivative is equal to 0, that will always give me my maximum and minimum points. These are what we call stationary points or turning points, because my graph goes from like increasing to decreasing. That's what they're called, turning points. The turning from or decreasing to increasing, or vice versa. So let's come back here. So we have three types of stationary points. We have a maximum turning point, we have a minimum turning point, and then we have a saddle point. This is usually where we have a repeated root. Right. So how do we find turning points? Right. So we find dy dx. We let it equal 0 and solve the equation, and then we sub back in the corresponding x values. So we sub back in the x values into my equation to find the corresponding y values. And then it's very important to determine if something is maximum or minimum. It's very odd, right? So you have to remember to think the opposite. If the second derivative is less than 0, then it's a maximum. If the second derivative is greater than 0, then it's a minimum, right? So you need to kind of think about that for a minute. So first derivative equals 0. If the second derivative is less than 0, it's a maximum. If it's greater than 0, it's a minimum. So let's have a look here. So let's look at this example here. So find the turning point of this function here. F of x equals 2x cubed minus 5x squared minus 4. So let's find the first derivative. The first derivative is going to be equal to 6x squared minus 10x minus 4. Let that equal 0. And I notice I can divide across by 2. That's positive 2 is positive 2, right? So 3x squared minus 5x minus 2 is equal to 0. Factorizing that, it's going to be xx, and then it's going to be minus 2 plus 1. So I'm going to have here x is equal to minus 1/3, and x is equal to 2. So I need to determine first if these are maximum or minimum. So I'm going to use my second derivative test. So my second derivative then is going to be 6x minus 5. So sub them in. So the second derivative evaluated at 1/3 is equal to 6 times 1/3 minus 5, which is equal to 2 minus 5, which is minus 3. That is less than 2, so therefore this is my maximum because my second derivative is less than 0. And then this one here, evaluated at 2, 6 times 2 minus 5 is going to be equal to 7. 7 is greater than 0, therefore this is a minimum. So now let's get my coordinates. So we evaluate f of minus 1/3 and f of minus 1/3. Minus 7, still the same thing, right? Minus 7 less than 0. Evaluate minus 1/3 and 2. Ding, ding, ding. Put them in here. I get minus 8 over 27 when x equals minus 1/3. And I get minus 13 when x is equal to 2. So my maximum turning point will be minus 1/3 minus 8 over 27. And my minimum turning point will be 2 and minus 13. That is how to define maximum and minimum points. And the other one we learned about is point of inflection. And point of inflection is the point in the line where it goes from a concave up to a concave down, right? And what's important to know about the point of inflection is it's where the second derivative is equal to 0. So I'll just walk you through this example here really quick. So here's my function f of x. I need to find the second derivative equals 0. So the first derivative will be 3x squared minus 18x plus 24. Second derivative will be 6x minus 18 equals 0. Let that solve for x. You'll get x is equal to 3. And then sub that in to find my corresponding, sub that back into my original function, find my corresponding y value. So f of 3 is equal to 18. So my point of inflection for this curve would be 318. So a point of inflection is where it goes from concave up to concave down. And a turning point is when it goes from increasing to decreasing. So let's just have a look quickly at just one or two exam questions. So this is from 2024. Find the coordinates of the point of inflection. So point of inflection, second derivative equals 0. So first derivative is equal to 6x squared minus 18x plus 5. Second derivative will be equal to 12x minus 18 equals 0. 12x equals 18. X is equal to 18 over 12, which is equal to 3 over 2, 1.5. Evaluate that now at 1.5, f of 1.5, so 2 times 1.5 cubed minus 9 times 1.5 squared plus 5 times 1.5 minus 11. That will give me minus 17. So therefore my point of inflection will be 1.5 and minus 17. So at the point minus 1.5 and minus 17, that is where this curve goes from concave up to concave down. Let's look at this one now. F of x equals x squared plus bx plus c. So we actually don't know the coefficients of b and c. F of x has a local minimum at 3 minus 1. So we need to use this information to find b and c. But I know when x equals 3, y has to equal minus 1. So I know that first. So f of 3 equals minus 1. So 3 squared plus b times 3 plus c is equal to minus 1. 3b plus c is equal to minus 1 minus 9 minus 10. There's one equation. And what we also know is this is a local minimum. Therefore, my first derivative, right, will be equal to 0 at x is equal to 3. So my first derivative, evaluate at 3, is going to be, so it's going to be 2x plus b is equal to 0. So it'll be 2 times 3 plus b is equal to 0. B is going to be equal to minus 6. Since b is equal to minus 6, shove it back in here. 3 times minus 6 plus c is equal to minus 10. Minus 18 plus c is equal to minus 10. C will be equal to minus 10 plus 18, which is 8. So b is minus 6 and C is 8. Right. I'll leave that there for today. In the next video, I might look at some exam questions, but I hope this video will help you guys. Bye.